They're not healthy, but they're the healthiest.
They're not the least awful.
And yeah, the least awful. So if I look at for this, we already saw that when we analyzed so the colors here are the clusters that I discovered in RNA sequencing space, in what we call gene space. They've just been arranged in a line from best to worst.
So blue is the worst?
The glioblastomas over here.
Okay. So for those listening, don't worry. We're going to link in the show notes to a video representation of this. Interesting.
At any rate, this is what you see. So this is the plot in biospace. Now that's very interesting because these have the dimensions of the biocoordinates, and those coordinates have a meaning, okay? In fact, I'll tell you what the meaning is.
And this is based upon a set of data of patients.
This is 692 patients. That data was submitted to the Cancer Genome Project.
Okay.
Oh, so this is open source data that you're pulling in.
This is absolutely open source. What
Got it.
my company did when we existed, because we had various projects going and things like this, we downloaded all of that data for the RNA sequencing data, and as much as we could find about each of those tumors, which was not a hell of a lot, but there's something. It's a good database. As I said, it's been studied for years and years and years. So this is results obtained by starting from no information and just re-looking at the brain cancer data and saying, people have been studying this forever. Did they ever find anything like this? And the answer is no. This has never been discovered. This has never been discussed.
So using traditional analytical sources, you could not
get whatever.
You could not get at this information without doing the dynamic quantum
because
clustering.
You make a lot of assumptions about what you're supposed to look at. You make a lot of assumptions about how you filter the data. You end up throwing the baby out with the bathwater. Go ahead.
No, you also said that you didn't do any cleanup of the data. Like, that's just the raw.
No, well, I mean, they've cleaned it up, obviously, at some level. But we're not doing the post, whatever they did, cleanup that people normally do, where they filter out genes where they have this gene should be expressed at least at this level. All genes that aren't expressed at that level, we're throwing out of the data set. Okay. If I see a difference between two clusters and the genes are expressed differently in the two clusters, but what they call the fold value isn't big enough, I'm throwing it out of the data. Well, you can imagine if there's hidden information in the data and you're busy throwing things away, the chance you throw the baby out with the bathwater is very high.